All of us at some point in our lives usually will lose some teeth, either by accident, by tooth decay or other diseases. And most often we would like those teeth replacing in some way. Traditionally that's been with a prosthesis, false teeth of some kind, and more recently dental implants have developed, which is essentially a metal screw that is inserted into the jaw and then capped with something that looks like a tooth. Many animals, of course, are able to naturally replace their teeth. We do it once, other animals do it multiple times, some do it continuously throughout their life. What we're trying to do is to understand how tooth replacement occurs naturally in animals and indeed in us, and then use that information combined with the knowledge that our teeth contain specialized stem cells to generate a biological implant, where instead of implanting a metal screw, we would implant a cell-based tooth primordium, which is an underdeveloped tooth that we've grown in the lab, that would develop into a completely normal tooth with all its roots and connective tissue.
So when we look in the mammals, this is a nice primate here, we find that there's only two sets of teeth, two generations of teeth. So you have your baby teeth at the start, and then they get replaced by the adult dentition. Now that's found in mammals as a general rule, but there are many animals out in the animal kingdom that continuously replace their teeth. So here are some shark teeth, and we can see they have this fantastic conveyor-like system of replacement, so that when one tooth falls out of the jaw, another one erupts, comes out and takes its place. And there's loads and loads of these teeth all hiding under the skin, waiting to replace the tooth that's fallen out. Now that situation is not seen in mammals, and we're interested in what is the difference between this situation and that. What controls the number of teeth? What prevents extra tooth formation in mammals? What are the cells that are contributing to these extra teeth, the stem cells? What are they doing and how are they regulated? And we're hoping that this information will really tell us a lot about the ability to make teeth and control tooth number in humans.
These are two examples of teeth that we have grown from cells in the laboratory, so-called bio-teeth. And as you can see, they resemble normal-looking teeth. They are starting to develop roots, and they have all the normal tissues that you would expect of a tooth: the enamel, the dentine, and the other soft tissues. So our concept of what tooth replacement would look like in the future is that we would obtain the relevant cells, the two cell types, the epithelium and the mesenchyme, that we would then grow in the laboratory to get sufficient cells. Those cells are then combined in a specific way to reproduce the combination of those cells that appears in the embryo just as a tooth starts to develop. Once we've grown those in the lab, we can then transplant them into the mouth, where they would continue to do what they would normally do in the embryo, but now do it in the adult mouth, and give rise to a completely normal tooth with all its normal cells and its normal attachment to the bone.